Good evening, everybody, and we are here for the very first ever Roundtable Fight Night. And we should be joined by Brenda, are you there? And Rightthe, are you there?
Yes, I am here.
Excellent.
And yes, I'm here.
Perfect. Right, okie dokie. So we're going to go through a bit of the protocols about how we're going to run this show. You guys are the first ones here, so it's a case of a bit of a guinea pig, really, for you two. But this is how I'd like the format to go, which is going to be, you've each got the questions, haven't you? You've got each other's questions that were presented to you yesterday.
Yes.
Yeah. Cool. Right. So you've had a chance to examine what the questions are going to be. So for this particular case, I think we're going to start with Rightthe, who will ask the first question. And then Brenda, you'll get a chance to respond. Rightthe, if you feel that, you know, in some way you haven't exactly got the exact answer you're looking for, you can perhaps ask a second question along the same line just to try and find out a little bit what it is that you're trying to find out in the question. And then once you've done that, I'll basically just give you a 5-minute free-for-all, because what I would like to have is I'd like to have like essentially a question and an answer, the best way that you can answer it, and then if you guys want to have a little discussion about that afterwards, the floor's open for a 5-minute chat, and that's what we're going to do with each question. So if you're happy with that?
Yes.
Perfect.
Yeah, sounds good, man.
Perfect. Right, okay, so we're going to do Rightthe, so you'll be first. So if you want to kick this show off and ask Brenda your very first question.
I'm actually loading it up, so I don't. I believe it was what does an atom look like, and if you can
let me
refresh my memory here. I'm loading up now, so I'll have the other 4. It's just
okay. Let me just double check. I'll check it on my emails. So 1 sec.
My bad. I didn't know we'd be. I thought we were going to be getting asked the questions, but.
Yeah, well, yep. You've got to ask the questions. So...
I thought you were going to be asking our questions to the like you would ask Brenda. All right.
Well, I'll tell you what I can do. I can ask your first question, but then I'd like you to ask the questions if that's all right. Yeah. Okay, so Brenda, what force keeps the electron from flying away from the nucleus? And is there a physical connection between them?
Well, the connection between them is the electromagnetic attraction between them, electrostatic attraction between positive and negatives. And what keeps them inside, or what keeps it from flying away is the electrostatic attraction. And you can visualize the atom as a box, and within that box, the electron is allowed only certain frequencies because it is a wave, or partly a wave, or described as a wave, and only certain frequencies at certain energy levels fit inside that box, right? So but basically what keeps it from flying away is the attraction between the positive nucleus and the negative electron. It's a force. It's the electromagnetic force. I hope that's an adequate explanation.
Okay. So you're saying magnetism. It's electromagnetism that keeps the electron from flying away from the nucleus.
Yeah, there are 4 fundamental forces: gravity, the strong nuclear attraction, the weak nuclear attraction, and the electromagnetic force. Right? So those are the 4 fundamental. These forces are mediated by the exchange of a particle.
Okay, before we go any further, Rightthe, does that somewhat answer the first question that you had? Because I can do a 5-minute session now where you two want to get into this, but essentially, do you feel that she's answered the question to your satisfaction?
Yeah, no, electromagnetism, that's her his answer, but I'd like to expound a little bit more on it, yeah.
Okay, cool, right, well, I'll give you 5 minutes, so if you two want to just crack on into this, away you go.
Well, I don't know.
Specific material. I just said, is there a physical connection?
Yes, there is. They exchange particles.
Okay, so there is a particle flying between the electron and the nucleus.
That's what all particle-particle interactions are, is an exchange of the particle that mediates the respective force. So the nuclear force, the strong nuclear force, is an exchange of the particles associated with the strong nuclear force, and the same is true for electromagnetism and all the other forces. And presumably, though we haven't detected it yet, the gravitational force would be the exchange of a graviton.
Okay, so you're saying that there is an exchange of some smaller particle than the electron and the nucleus between those two?
Yes, yes.
Okay, and how would you back that claim up?
Well, that's just standard quantum field theory. That's what these particles. This is just textbook science, and this is what they tell me, which is that forces are mediated by their associated particles.
So you're just telling me what somebody told you?
Yeah, that's what a great deal of learning in school is understanding what other people have understood.
Are you understanding it, or are you just repeating it?
I understand it.
Oh, wouldn't you need to? Okay, so if somebody was like, I understand what planting a seed is like, but somebody else has actually planted the seed, does one person understand it, and the other person understand it, or does one understand it and the person who hasn't done it can only assume what it's like based on what they've been told?
I think I can understand what it means to plant a seed, even if I've never planted a seed. I can understand that. I can just imagine it in my head. Oh, there's a piece of ground. I have a seed in my hand. I plant the seed in the ground. That's not hard.
Okay, so you would agree that everything that you just described with the atomic nature and the connection is imagined by you?
No, it is based on real-world physical experiments that other people have conducted using equipment I don't have access to.
So you personally have never witnessed any of the things that you're trying to tell me exist, but you will say they exist because you understand what other people have done?
Well, I have seen the results of those experiments. I have seen the traces in cloud chambers that the physicists have conducted those experiments and how they correlate to what they are saying as far as quantum field theory goes, or for any other theory. I've never flown a plane, but people can tell me what it's like to fly a plane, and I can figure that out. I don't have to.
We're not sure.
I don't have to do everything. I can learn by people talking to me and imparting their knowledge to me, and I can understand and conceive of and remember that information.
Okay, so how would you know somebody's lying or telling the truth if what they're telling you can't physically see? So if I told you that it's not atoms, but it's actually little unicorns, how would you say that it's wrong if you've never actually seen it, you've only seen the effects?
Or the same way I could tell if somebody's lying to me about the Eiffel Tower in Paris, France. I've never been to Paris, France. I've never been to France. I've never been to the Eiffel Tower. But if somebody tells me, well, it's made out of chocolate, then I could find out that is wrong, because nobody else says that. Everybody else shows us pictures, and it's actually made out of steel, and therefore I can reasonably conclude that the Eiffel Tower is made out of steel and not made out of chocolate. So
okay, but what if they told you it was made out of something you've never seen? You've never. Let's say it's made out of unicorns, and you've never seen the Eiffel Tower, and you can't see the Eiffel Tower. How would you know it's not made out of unicorns? Because you can see the Eiffel Tower.
That's the 5 minutes up. So essentially what we're going to do now is we're going to go to question 1 from Brenda. But bear with me, guys. When all these questions are finished, I will give you 15 minutes at the end for you guys to revisit any of the questions that you don't feel you've actually had a thorough answer to. But if I don't keep it structured, essentially what's going to happen is it's going to just run away and time's just going to elapse.
I like it. I think if you can't make your point or you can't, do it, don't let it ramble on. So, yeah.
Okay, Brenda.
Okay. Oh, my first question is, what is your highest level of education?
Okay, so I'm going to assume you meant in education, the scholastic school system. I went to college and got a degree. So, and if that satisfies your question.
A degree in what? What degree in which field?
I got a degree in HVACR.
I don't know what that is.
Oh, that's your problem, Brenda.
Okay, Brenda, would you be happy with that answer? Are you not satisfied?
No,
would you like a little bit more?
I don't know what that is, and I don't.
Well, it's my fault that you don't know what I majored in and what I know. I'm sorry Brenda, I'm sorry you don't know everything, okay? That doesn't mean that I don't or that you know more than me, okay? You wanted to know what level of education, which is what level of indoctrination and repetition and memorization did I achieve? I made it through college and I got a degree. Congratulations. I did what everybody expects people to do. And then I left that and realize that real education comes from the experiences of tangible matter that you know and can verify yourself, not from what you're told with 40 other people in a room.
Okay, guys, I'm gonna give you 5 minutes starting now, guys. So
okay, what did you say that was? HVS what?
HVACR.
I still don't know what that is.
That's not my problem, Brenda. That's not my problem. I'm sorry. Hey, if you were,
I'm just curious. It's not a
gotcha.
That is.
It's not a gotcha. But what do I have to explain? If I was a dentist and I used a dental term and you didn't understand it, would I have to explain dentistry to you? No, I'm sorry. If you're not educated on a jack of all trades or a wide enough scope of information that you're going to try and attack my intellectual capability because you don't know what HVACR is. Your entire premise of this entire premise of your first question was trying to label me as some sort of person who has no intelligence.
No.
Yet the fact that I graduated from college with a degree in a field that you don't even know what the letters mean shows that you're the one that lacks real world experience and you only have parroting and a repetition of what somebody else told you.
Dude, it's not a gotcha. I'm not trying to get
know
you.
It's not a gotcha.
I'm just curious.
And I told you. I'm sorry you don't know what those letters mean.
Yeah.
I'm sorry you're ignorant of those letters. If you want to find out more, take some time after the debate. Go Google those letters. I'm sure you tried. Maybe it didn't come up with, but they are a real thing that you can specialize in and figure it out. Okay? I'm not here to hold your hand through life. You asked me a meaningless, pointless question. I gave you a real answer despite the retarded nature of the question, and it's moved on. We've proved nothing about quantum mechanics by you questioning about my educational background.
Well, it was just the first question that popped into my mind. I have a high school education. I did not complete college, but I guess your degree in heating, ventilation, and air conditioning is what you got, right?
I have college credits and I have a degree. I have more than just that degree from that particular thing.
You have a degree. You have a degree in air conditioning and refrigeration. Okay, that's fine.
As well as college credits, and all I would have. You've never been to college, so you don't. So let me explain how it works. You don't go in. When you go in there, you get credits. Okay, credits are paid for.
It's not a big deal.
Hold on, let me finish. I know. Let me just explain it since you're ignorant. So you pay $200 to get a credit. Now, if you wanted to get a degree in, let's say, X field, you would need to take certain classes, whether you wanted to or not. Okay. I just have to go back and take these retarded classes that were mandated on me, buy a whole bunch of books I don't want to buy, and I could get any degree in any field I want, but I don't want to do that because that's a waste of time, Brenda.
That's fine. It's not a big deal. Let's move on.
Okay, guys, if you're happy to move on, I'm happy to move on too. Right hand, do you have the next question?
I do, yeah, I was able to get it. Okay, so Brenda, what does an atom look like, and how do we know that's what it looks like?
Well, you can't really see an atom because it's below the ability of your eye to see, right? So we use instruments, an electron tunneling microscope, to visualize atoms using the principles of quantum dynamics. You can move a very tiny recording head over the surface of a material, and due to quantum tunneling, you can get an image of the material beneath it, and basically it looks like a solid that's packed with tiny little billiard balls.
Are you happy with that question, that reply?
I mean, yeah, that's it's. We could go more into it, but it's.
Yeah. Oh, no, you've got 5 minutes if you want to carry on.
Yeah, no, I'd like to carry on that one.
Okay, all you're gonna see with an electron tunneling microscope is the outer shell, right? And the inside of it is going to be a very tiny nucleus, and the rest of the space is mostly empty, but it's going to consist of various electrons, depending on the material, at different energy levels, and those energy levels are described by a probability cloud, which you would learn in physical chemistry. And those probability clouds have different shapes, but the outermost shape is most likely going to be most likely a sphere. I would imagine. I don't actually know.
So wait, but if we've seen a picture, how come you don't know what it looks like?
You can't see it, but we can.
Oh.
We can
so
describe
how do you know what
it.
It looks like?
We can describe it mathematically, and other people can talk to you about that. We can understand how it looks, but you could never see an atom because you need light to see with, right? And light at that level, you just wouldn't be able to see it because we're at the level of quantum mechanics.
Okay, so would you agree that you don't know what an atom looks like, or even if atoms are real, but you just get an interference pattern?
Oh, we know that they're real.
I didn't. Well, no.
But the ability.
Hold on. You answer the question. Are you looking at an actual atom, or are you looking at a probability distribution?
When you look in a textbook or in any kind of representation, you're looking at a representation, right?
That's so not the actual thing. You're looking at an interference pattern that gets
too small. It's too small to see. It's too small to see, but you can use an electron tunneling microscope to. There are in fact images you can find on the internet. I'm sure you have seen it. Yes, it's just a tiny. There's
images of unicorns. Okay, but that's an image that is based off of a mathematical probability. Do you understand that? That's what that is.
In the case of an electron tunneling microscope, it is an image of the material.
No, it is not.
Why not?
Okay, have you ever seen the pictures? Have you ever seen the pictures from it's not the actual material. It looks like graphs and charts and probability distributions.
No, I'm talking about the image from an electron tunneling microscope itself.
Okay, so the only way you can prove an atom is that I have to trust an image from a source that I can't verify myself, from a machine that I can't use myself.
Basically, science is built on trust. It's a community of people who check each other's work. Science is a collective. So no, that's not. Well, it's trust. If you want to equate trust with faith, that's fine.
I don't want to. I'm trying to say, if you've never seen it, you've never done it, you've never witnessed it, you've never experienced it, you're going only on what somebody else told you. How is that not faith?
It's trust. If you want to equate trust with faith, that's fine with me. But most people, by faith, they mean belief without evidence. But I have belief with evidence. The evidence of the collective activity of a community of scientists who follow the scientific method check each other's work, publish, and recheck and double check their work, and plus the theories that are based on their experiments actually work in the real world, and they don't. A theory based on magical unicorns does not work. One based on atoms does.
Okay, but the idea is this: you're not basing the theory on atoms. You're basing it on what happens to things. So when you electrocute or add electricity to something, it behaves a certain way. You think it's because of atoms. It doesn't matter. All you see is what you see. That's what we get our information from. The actual tangible interactions of matter, not your explanation. Quantum mechanics did not make a computer.
I disagree.
Physical objects did.
I disagree. That is not how we know things. The way that we know things is we are not limited to our own personal experience. We can use the experience of others, what they have done, what they have written, what they have talked about, the experiments that they've done, the results of those experiments, and how those experiments are checked and double checked.
Time's up on that one, guys. Time's up on that, guys. Okay, no worries, no worries. Brenda, it's actually your question now, so question 2 if you can.
Okay, Rightthe hand. How do transistors work?
Transistors work based on the properties of metal and how it conducts or doesn't conduct electricity.
Metal conducts electricity. What are you talking about?
There's different levels of conductiveness. You can be very conductive, kind of conductive. You can be more conductive than others. I can show you a chart of conductivity if you want. It shows which metals are more conductive based on tests that they've done with those metals.
But that will not explain how transistors works, because transistors work based on the principles of quantum mechanics.
No, they work on metal being electrocuted and you seeing the results.
Okay, Brenda, are you happy with his answer? And then we can get into a 5 minutes debate on this.
Okay, let's go with the 5 minutes on this too.
Okay.
How can adding electricity to a transistor cause it to switch off?
This transistor doesn't switch off, okay? It changes, hold on. So when you start electrocuting metal, okay, you're going to see an effect based on how much energy or electricity you apply to that metal. If you use a semiconductor, you're going to get different effects than normal metals. But the only way to know what effects you're going to get is by electrocuting that metal or adding a charge through it and seeing how it behaves. From that observation, you then do whatever you need to do. But you can't prove what is causing the conductive nature of the metal, only that you're observing the effect.
Rightthe hand, that's incorrect, because with a transistor, you can have the two parts of it, the N and the P side, and then you can have a third wire or conductor, and whether or not you pass a signal through that, it can turn the electroconductivity of the N and P on and off, and it can act as a switch. How can conductors act as a switch under classical understanding of electricity? It can't. Only under quantum mechanics can explain the ability of another conductor to cause the N and P sides of a transistor to turn on and off.
Okay, so what you just did was you witnessed an event, and then you came up with a story for why it happens, and then said, this story is the only story that explains it, and nothing else can, therefore this story is correct.
You don't have an account, though.
I don't need one. I don't need one.
Yes, you do.
Yes, I don't need, hold on. I don't need a magic trick of my own to point out that you're doing a magic trick.
I'm not doing a magic trick.
I just pointed out how you're doing a magic trick.
I can build computers and radios based on transistors and on the understanding of quantum mechanics, and you can't build anything. You can't build anything.
Hold on. You do
You
not
can't
build,
build anything.
Hold on. You don't build a computer based on your understanding of quantum mechanics.
Yes.
Hold on.
Yes.
You build a computer based on how you've seen physical matter react to electricity.
No, because you would never come up
hold on.
with a
So let me ask you a
computer
question.
or a transistor.
How do you know how a certain metal conducts electricity? Tell me how you would know how iron is going to conduct electricity without sending electricity through iron and observing it.
What do you mean? Well, of course you send
Okay,
electricity through it. Then you would measure.
hold on.
You would measure its resistance and how much electricity it can hold, and things like that, right?
Okay, so you can't find out anything about conductivity without first doing the adding of electricity to a metal, right?
That's false.
Okay,
Right,
so then, So I asked you before, can you show me how you're going to find out how a metal reacts to electricity without sending electricity through it and observing it? How are you going to do that?
Well, you would do it based on the principles of quantum mechanics and and materials. Just a minute. And materials engineering. Materials engineers can know how a material that they have not yet constructed, an alloy or a metal or a semiconductor, how it will behave before they even construct it. And they can predict its properties based on the theories of quantum mechanics, and then they can build it. And that's a hallmark of science, is the ability to predict and to make predictions, right?
They're not making, hold on. They're not making, it's not a prediction when you take the metal, add electricity, quantify what happens, and then say, this is what will happen. That's not a prediction. That's quantifying what you experimented with. And now if you're going to say, but there are people in a lab somewhere that did an alloy, and that's a baseless claim, and more faith in people in places you've never been, using machines you'll never use.
You're simply wrong. Material engineers can, in fact, create materials theoretically, and then they can build the material based on those properties. They can build materials to order, to whatever the client wants those properties to be.
Okay, time's up, guys. Time's up, guys. Right, so we're going to have to move on now. Question 3, right the hand.
Okay, question 3. Is there a vacuum of nothingness between the electron and the nucleus?
No, there's only a probability cloud.
Wait, so but a probability cloud is the chance of where your quote-unquote electron will be. So
right.
There's going to be holes in the probability cloud. Does that mean there's nothing there?
I don't know in that case, but for the most part, it's not a nothingness because it's too small to be actually considered a vacuum. It's the space between the electron and the nucleus is occupied by the probability clouds of the electron shells, right?
Is a probability?
Does that answer the question though? Is that what you wanted from the question?
I mean, I would like 5 more minutes.
5 more minutes, perfect. I mean, that's what we'll give you 5 minutes. It's not a problem. Here we go.
That's what we're doing.
Hold on. Is a probability cloud a physical object?
No, it's not.
Okay, so then a probability cloud cannot be occupying the space around the nucleus, correct?
Well, that is all that there is between them.
But you just told me that a probability cloud is not a physical object.
Okay, well then I'd have to say I don't know what there is between them. There's a nothingness. But very likely, another possibility would simply be there are virtual particles coming in and out of existence in the space between an electron and the neutron. I mean the nucleus.
You think there's particles coming in and out of existence?
Virtual particles.
So what is a virtual particle?
And those are particles that don't exist long enough to actually be considered real particles. They create spontaneously out of nothing, and they are created in pairs a particle and an antiparticle, and then they annihilate each other. And they do so within the Planck time, and therefore they're not really considered to be real.
So it's a particle that phases from nothing into existence, and then it's in existence for such a short amount of time that it's considered to not be real.
Yes, that is correct.
Okay, and that is what's in between the nucleus and the electron.
I could be wrong. I'll go with that answer until somebody tells me that I'm incorrect.
All right. Well, that's. Okay. I'll leave it at that.
Yeah, it's called the basic is due to the Heisenberg uncertainty principle, and it's the quantum foam that fills all of space, and is due to the Casimir effect.
Okay, those aren't physical things, so you just need
actually it is.
Effects.
The Casimir effect can be measured. It's been experimentally verified. It's measurable.
A measurement doesn't prove anything.
Actually, it does. If you can measure something, it's real.
No, but I could
really.
I can measure how much.
If I can measure something, it's not real. Is that what you're saying?
You can measure how much you love somebody. That doesn't mean love is a physical, tangible thing.
Well, I think love not physical and tangible, but it's still real. I think love is real. It's a real emotion. It's a real emotion that people have.
Okay. Do you understand real means like tangible in reality?
No, that's not what real means.
Oh, well, I think that's one of the problems you have, is that you think fairy tales can be real.
No, I think that ideas are real, and they are not physical things, but they are ideas that you have in your mind, right? And they're real. You can't measure them. You can't touch an idea, but it's still real.
How do you know it's how do you know it's an idea? How do you know it's not something physical inside of my physicality? Or how do you know it's not something metaphysical? How do you know it's not proof of metaphysicality?
I don't know what those words mean.
Metaphysical means that there is no explanation for it in reality, and it has to be from an outside physical nature. Like it can't adhere to reality.
Oh, I think ideas have a physical explanation. They are the activity of the neurons in my brain.
Okay, but that's an assumption because you've never seen an idea. Okay, so you only assume how and why it happens. It's the same thing with that virtual particle. You've never seen it, you just assume it.
Well, your idea of how we can know things is very limited and very strict, and I think it's too much. I can know things even if I don't personally witness things. I can make inferences, and I can I can make inferences, and I don't have to personally witness things.
So, but then you don't know it. You've inferred it, and inferring something is different than knowing.
An inference is knowledge.
No, knowledge is knowledge. An inference is when you you make an assumption. An inference is you take all of the evidence that you have and you make a gut decision. That's an inference. You don't know for sure.
Okay, guys, that's time up on that one, I'm afraid.
Okay.
Brenda, do you want to ask question 3?
Okay. What physical principles explain how fluorescent lights work?
So the physical physical principles of a fluorescent light are a glass airtight tube with some sort of electricity conducting material inside of it.
There's no conducting material inside of it. What are you talking about? It's gas.
Okay, and does that gas conduct electricity?
But what are the principles on which it works?
Hang on, before we get into this though, guys, Brenda, would that answer your question there, and then we can have the 5-minute countdown?
Well, what I'm going for here is the fact that fluorescent lights operate again by the principles of quantum dynamics, right? And that's how they work. And this is going to be another. This is in addition to the transistors. This is going to be another subject in which he can't explain how simple everyday objects work, and I can.
Okay, I'll give you a 5-minute countdown starting now, guys.
So the way that fluorescent lights work, right, is that there is an anode and a cathode, and electric charges pass between them, and it excites the atoms that are inside the vacuum tube, inside the fluorescent tube. It excites them, and they bump up to a higher orbital, right, and then after a period of time, they fall back down into their normal orbital and emit a light, emit a photon. They emit energy, and that's how fluorescent lights work. And that's not something that Rightthe can explain, because he doesn't believe that atoms even exist.
Okay, the fact that I can explain unicorns, that doesn't mean unicorns are real. I can explain a fluorescent light. God creates magic that makes it glow. The explanation, even though it satisfies how the light works, God's magic can do whatever, that doesn't mean it's right. Okay, just because you have an explanation that deals with atoms and electrons and photons and morbons and gotons doesn't mean it's correct. So yes, I have an explanation as well. It's God's magic. Now, if you can't hold on. No, I'm being serious. You can't see an atom. I can't see God's magic. Atoms explain it. God's magic explains it. How is that any different?
So you're not being just facetious. You're being serious. That God's magic.
You're talking about things I can't see.
I'm just asking.
I mean, you wanted an explanation.
Dude, let me finish. Come on. I just want to be certain that you believe that God's magic is what explains how fluorescent lights work.
You asked for
you're not
being
silly.
You asked for a explanation. I gave you one.
Does that mean my explanation?
Okay. Does that mean my explanation is correct?
Hold
on. Yes or no? You asked me for an explanation. Does it mean it's correct? Yes or no?
Your explanation makes assumptions that are unnecessary.
Okay, so does yours. You assume atoms.
No, I don't, because I can prove that atoms
exist. Okay, so show me an atom.
Yeah, this would
and not an interference pattern.
Course, right. This would require a course in high school chemistry and physics that you apparently
I completed high school.
Want to reject.
I never saw an atom.
I can back up. I don't have to presuppose a God who does magic and makes fluorescent lights work. No, I don't presuppose it. No, I don't. It's based.
So show me an atom.
I can't show it to you here.
I can't show you God's magic either. So how do we know it's not God's magic?
We can show experiments that demonstrate the existence of the atomic theory of matter quite easily. High school students, junior high school, junior high school students do this all the time.
Hold on. You said it will show evidence of a theory.
Yes.
One, how do you show physical evidence of a theory when you've never seen the atom? Where's your physical evidence?
This is how science works.
No, what's the physical evidence?
Dude, the way science works.
Don't tell me how science works. Tell me what the physical evidence for an atom is.
Stop interrupting me. The way science works is that we make observations, construct hypotheses, do experiments based on those hypotheses, from which we eventually lead to making theories that explain the results of our hypotheses and experiments. The atomic theory of matter is a well-established scientific theory based on direct observations and experiments. If you don't believe it, you can conduct the relevant experiments in junior high yourself.
Okay, you said direct observations, but then you said we don't directly observe an atom, so you're contradicting yourself.
Yes, you don't have to directly observe a thing to know a thing.
But you just said from direct observations.
Right.
So you didn't get a direct observation.
That's right.
You got an so you didn't use a direct observation for atoms. So you got an inference from an interference pattern.
Yes.
So you assumed, based on an interference pattern, that atoms are real. How do you know it's not God's magic?
Well, because it's not parsimonious. That's one reason why.
Well, I don't think atoms are parsimonious.
Well, they actually.
Okay, guys, that's your time up. I am sorry, but we've got to move this show along. Rightthe hand, if you want to ask your question 4, please.
Okay. What are electrons made of, and how does combining them in different formations result in different compositions of matter? I don't care how you stack a bunch of wood, you're never going to get bricks or marble.
Yeah, electrons are fundamental point particles.
Can you expand on a point particle?
They are points, right? And it is a point charge. An electron is a point charge. It is a fundamental particle. You can't subdivide it any further. That's what an electron is.
Does that answer your question, Rightthe hand?
Yeah. Okay. I'd still like to go.
Okay.
Yeah, we can have the 5 minutes starting now.
So every electron is made of the same thing, right? Some tiny little charge.
They're not made of anything. They are simply electrons. They are fundamental. They are not composed of anything. They are a fundamental particle.
But
Particles
it has a
are not
physicality,
made.
right?
No. If it's a
electron has no physical nature.
It's a point charge. Yes, it does. Sure.
Okay,
certainly
so
it has charge. It has charge.
But I'm asking about physicality. Does it have physicality?
They aren't made of anything.
So it has no physicality.
No, it does.
It has physicality.
It's a fundamental. You're trying to think that there's a substance of which electrons are made out of. They're not made out of anything. They are the fundamental. Nothing. Just a minute. They are the fundamental unit out of which everything is made.
Okay, so everything is made out of the same fundamental unit, but we have hundreds of thousands of different materials. How does the same fundamental unit come together to make different materials?
Right. So there are other fundamental particles like gluons and other fundamental particles, and how they are arranged is what constitutes material. So neutrons and protons are composed of gluons, an up and a down, in different combinations of up and down gluons, right? And so how they are arranged is what constitutes a neutron or a proton.
Yeah, but you're still, okay, if I had 7 bricks and I arranged them differently, you would still have bricks. How do you arrange these, how do you arrange these quarks and gluons differently to get grass and glass and drywall and metals and gases and water? How does that happen?
That's a good question. And the thing is they follow a set of rules. They don't just stack together. They're not like blocks. There are rules about the ways that they can combine, right? So there are only a certain ways that they can combine. So you have to have at least one proton and one electron, and right? Or you can have 2 protons and 2 neutrons and an electron, or a number of electrons, and those are the various elements. All of the elements are composed of protons, neutrons, and electrons in different arrangements according to the rules of physics, which is quantum mechanics.
Okay, so you're saying that iron, gold, boron, tin are all made out of the exact same thing, just arranged differently.
Yes.
Does that make any sense? How do you? Okay.
Yes, that makes
how do you arrange? Okay. Yes. Okay. So I'm going to ask. I'll follow that up with, can you arrange anything else? Okay. Can you take little bits of sand and arrange them in a formation and make wood?
No, because sand isn't wood.
Okay.
It's not a sand is not Sand. That's not a point. Sand is not a fundamental particle. Gluons.
Yeah. A fundamental particle doesn't change. Doesn't become gold at will. It doesn't become iron at will. If you have a fundamental particle, you have that. You don't have something that morphs into different things like a human stem cell.
Well, think of it this way, Rightthe. This is actually it's a good question that you asked. The only difference between iron and gold is the number of protons, neutrons, and electrons and how they are arranged. And you can make gold.
So would you say that
you can make gold? Just a minute. Just let me finish. You can make gold in a cyclotron. You can make it.
If I gave you 10 pieces of wood, 5 pieces of glass, could you arrange them into any other formation except for wood and glass?
Well, I can make a house, right?
But
I can make a house.
It will always be made of the materials that you started with. You're never going to combine those fundamental materials into something else.
That's correct. The protons, neutrons, and electrons.
That's what you're saying.
Just a minute. The protons, neutrons, and electrons that compose iron and gold do not change. What makes gold gold is how they are arranged, and the number.
Time's up, guys. I'm afraid. Time's up. I'm afraid.
And how it interacts with its environment. That's what makes it what it is.
Okay, Brenda, would you like to ask question 4, please?
If I use a pressure gauge to measure tire pressure, have I not changed the pressure in the tire by observing it?
Yeah. Are you observing it or physically interacting with it?
The only way that I can know the pressure of the air in the tire is by measuring it with the tire pressure gauge. And so that's an observation. That's an observation.
You didn't answer the question. I'm going to ask it again. Did you observe it or did you physically interact with it?
I observe the reading off of the tire pressure gauge.
How did you get the...
Before you carry on, guys, are you happy with that response, Brenda, to your original question?
Well, he hasn't actually responded yet. He's asked me questions back.
Okay, would you like to ask the original question again? And then Rightthe, if you'd like to give an answer, right. And then we'll come back in 5 minutes.
Okay, I can answer it again. If I use a tire pressure gauge to measure tire pressure, have I not changed the pressure in the tire simply by observing it?
I'm saying you did not, quote, simply observe it, end quote. What you did was physically interact with it, which is not the same as an observation. An observation would be you, an observation would be you looking at the tire. A physical interaction would be you squeezing the tire with your hands to see how hard it is.
No, you're wrong.
Okay, guys. What I'm gonna do is I'm gonna give you 5. I'm gonna give you 5 minutes now, guys, because you've had the response from Rightthe, and I'll never make anybody answer a question if you don't feel that they've answered it correctly, or whichever way they answer it how they want to do it. So you guys, you've got 5 minutes now, so enjoy yourselves.
Okay. You're wrong. Any measurement is an observation. Any interaction is an observation.
No, okay. But in this particular instance, you not only observed the pressure gauge, but you physically interacted with the object. So let's say, for instance, you had a NASCAR car going around a track, and you used a stopwatch to time it. That's a measurement that does not interact with the NASCAR car. But if you took some sort of... Okay, how does me with a stopwatch affect the NASCAR car going around a track?
There are photons coming off of the car that are impacting that's a physical interaction. I can't know they're there without those photons bouncing from the light from the sun, bouncing off of the car and hitting my retina. That's how I know they're there. That's a physical interaction.
How do you know that's what's happening?
There are all physical interactions or measurements are observations. That's what it means in science, at least. Maybe not in common usage, but in science, any measurement is an observation.
Okay, so are you saying that me looking at the NASCAR car, I am slowing it down somehow by the photons that are bouncing off of the car?
You are interacting with it. It's an interaction.
Okay, so you have to assume photons, and then you can say I'm interacting with it, and then you can assert that my observations are changing it, because I'm not just observing it, I'm actually physically interacting with it.
Yes.
So it's not an observation. So you're saying observations are physical interactions, right? Isn't that what you're saying?
Yes. You can't know that anything exists unless you physically interact with it.
So I can't look at something and know that it's there?
By looking at something, you are physically interacting with it.
Okay, well, I disagree. I would ask that you prove that.
Okay.
Or provide evidence.
This isn't even high school or junior high science. This is like what we teach children, right?
Well,
the light.
Did you not graduate high school?
You can only know things that exist because light bounces off of them.
Okay,
and
you just said what you said again.
Yes.
Okay, you just yes. So stop saying it. Okay, because I know what you're going to say. You're just going to reassert it. Now show me evidence. Show me evidence of it.
Oh, I turn off the light and you can't see.
The light goes off. I don't see photons.
Yeah. You don't know, but you don't.
That doesn't mean photons are real, Brenda. That doesn't mean photons are real. That just means you turned off the light.
Do you see the car?
That doesn't mean photons are real. It means you don't see the car.
Well, the light generates photons.
No, you assume the light generates photons.
No, we know that from prior.
Show me evidence.
Science.
Turning on and off a light isn't proving photons. So
Yes, it does. What are you talking about?
Turning on and off a light proves photons?
No. Yes.
Yes or no? Pick one.
Yes.
Okay,
yes.
So
light.
So we don't need to do
turn
any
the light on and off.
How do I? Can I see a photon?
Can you just stop interrupting me, please?
I can't stop. I'm observing it, and by observation, I must change it.
Turning a light on and off shows that it emits something, which is necessary. Can you fucking stop? It shows that it is emitting something which is necessary for us to see, because without the light we can't see anything.
You're right. Without light we can't see, but we don't know that light is photons flying off of it.
Actually, we do.
Okay, and again, show me the photons so I can see them and know that that's what's happening.
Photons are quantum parts of light, and it was shown. It was demonstrated with the photoelectric effect.
That demonstrated a rainbow.
No, it didn't. It demonstrated that you're confused. The photoelectric effect was had to do with black body radiation, right? And there's a certain and it showed by Planck that light is only emitted in quanta, in certain energy levels. It's not continuous. It's quantized.
No, that's not what it is. You got an interference pattern, and then assumed based on that's what's happening, because you know what is happening.
Guys, that's it, I'm afraid, for that section. Right the hand if you'd like to ask your final question.
Yeah, I mean, it sums it up. Do you agree that everything you know about an atom is based on an interference pattern on a graphite medium?
No.
So then show me, outside of an interference pattern on a graphite medium, evidence of an atom.
I don't even know what the hell you're talking about. What do you mean a graphite medium?
Okay, guys, I think you've had your answer there, so I'm going to start the 5-minute countdown. Here we go.
So when you take the double slit or anything like an electron microscope, you're not actually seeing the atom. They send energy through whatever, and then they get what you call your probability distribution cloud. That cloud is an interference pattern created by the energy sent through the material onto a medium. And from what they see, they say, oh, there's more spots here than there is here, so that must mean the electron is in this area more than this area.
Yeah, it's a wave, right? That's
No,
what
I'm
it
saying
is.
that's a interference pattern on a medium. You're not seeing the thing you think you're seeing. You're just gathering your information from a interference pattern on a medium.
Well, when you say graphite medium, I have no clue what you're talking about. What are you talking about there?
Okay, so you know that we can't visually see an atom, right? You admit to that as well, right?
Well, of course not, but yeah.
Okay, so how they gather information, would you agree that they send energy through the atom and then gather on behind it on a collection plate to see how that energy was manipulated, and it creates a pattern on that plate?
Right.
Okay, so everything you know about the atom comes from that, right?
Right. So Rutherford shot X-rays at gold foil, right? And based on how the X-rays were diffracted by the gold foil, he was able to deduce the structure of the atom, right?
Okay.
The structure of the gold.
My point. No, my point is it's a deduction or an assumption based on an interference pattern.
Deductions aren't assumptions; they're deductions. So what he did is he was extremely surprised because he and his researchers shot an X-ray at gold foil and it bounced back.
Yeah. Okay. And they got an interference pattern. They didn't see atom. Okay. So they have the interference pattern, right?
Yes.
We agree? They don't have physically seeing atoms. We agree?
Right.
Okay. So they made the atom and everything they know about it from that interference pattern, right?
They deduced its structure from.
I don't care what they did. It's
you don't
from the
care?
Interference pattern. Well, I don't care what they did. I care about the source, and the source is the interference pattern, not an atom. Correct or incorrect?
So I want you to not interrupt me, please. So what X-ray crystallography is when you expose a crystal of a material to X-rays, and you get a diffraction pattern from that. And then you can conduct mathematical operations on the results, and you can deduce the atomic structure of the crystal from that. Go ahead.
Yes, you're deducing, or you're assuming the structure based on an interference pattern, not on the actual physical structure and observation of it. Yes, I know. That's my point.
Yes.
Okay, glad we
that's math. It's deduction. It's not a guess.
Not
it's
science,
not a guess. It is science. It is
you just
science.
Said it's math. You just said it's math.
Yes.
So math equals science?
Math is a tool used by science.
So is it math or is it science?
What are you talking about? Math is a tool used by science.
Okay, so you
write the hand. Write the hand. Write the hand. If I give you 2 apples, and then Sally gives you 2 apples, how many apples do you have?
Did you prove those apples were made out of atoms by giving them to me?
Write the hand. If
I've answered my question. So we're not talking about apples. We're talking about atoms.
Sally.
So are you proving
no,
atoms
we're not.
by giving the
atoms?
Okay, so then why are you bringing it up?
We're talking about math. Sally gives. Let's change it a little bit. Sally gives you 3 apples. I give you 2 apples. How many apples do you have? You have 5. You have 5 apples. You have 5 apples. Just a minute. Let me finish. You have 5 apples, and you can know that you have 5 apples by deducing that 2 plus 3 equals 5. That's math.
Math is a concept. You cannot have 5 of something. You cannot have 5 unless you have the physical reality. Okay?
But
math proves nothing. Math proves nothing.
Well, okay, guys, that's all over. I'm afraid that one. So, Brenda, it's your final question.
Okay, my last question is: what is a photon? Under your understanding, your understanding, what is a photon?
A photon is a figment of your imagination.
Really?
Yes.
How did you come up with that?
Because I've never seen it. It's like the tooth fairy. I went to bed one night when I was 8 years old with a tooth under my pillow. I woke up and there was money there. Does that mean the tooth fairy's real? You see the light turn on, therefore the tooth fairy's real. I don't follow.
Does that answer your question, Brenda? Then we can get into this a little bit deeper.
Well, if he wants to get into I can tell you what a photon is. He cannot. I can explain the physical world around us. He cannot. All right. For me, a photon is the smallest unit that the electromagnetic spectrum comes in. It's a quantum. It's a quantum unit of the electromagnetic field.
I'm aware of that. But I just think, so now prove that.
Well, I don't have to, because I can explain the world around me. I can explain chemistry, physics, biology, everything around me by using the relevant scientific fields of and the atomic theory and the theories about light, the theories about chemistry, how things combine and dissolve. It generates biology and chemistry, and you can't explain anything at all. All you have is magic. Your God magics light into being. That's what you said yourself, is that God is magic, and everything around you is magic.
You asked for an explanation.
Not magic. Magic is not an explanation. It is not explanatory.
Okay, do you want instead of calling it magic, I'll call it a photon. Would that make you feel better?
No, because we already have a word for that, and it just confuses things.
Well, yeah. That's the.
How do you explain?
Brenda, hold on. Let me. This is a very important point. Explaining something doesn't do anything. Okay, I can explain a unicorn. I can explain a UFO. I can explain why a red light turns red, yellow, green. That doesn't mean anything. It only means that I can come up with a story that kind of makes sense. That doesn't prove the cause.
Okay.
That doesn't. Am I making sense here?
I understand what you're saying, but what you're saying is wrong. Explanations lead to understanding, and when I have an explanation of a phenomenon that I observe, I can then make predictions. I can build things based on those explanations. I can build build new chemicals, new materials, new substances with which, based on my understanding of how the world works. You have nothing. You can't explain anything.
Hold on. You don't have, you can't create new chemicals based on your understanding of quantum mechanics.
Yes, we can. Yes, we can, and we do. We can, and we do.
Okay, so let me finish. So in order for you to create new materials, you must first experiment with physical materials to see how they act. You can't sit in your room with a notepad and go, I think I'll dig into the ground, and if I find a hard substance, I'll heat it up, and I bet you it will turn into a liquid hard substance. You can't do that. You need to go outside, dig into the ground, find the physical object, interact with it, do your tests, find out how it behaves, and then move forward. Your explanation is meaningless. Your explanation is meaningless in getting forward and getting knowledge. Knowledge comes from the interaction of matter and finding out how it behaves, not from your explanation of what happens. Your explanation is worthless. Your explanation is your own personal little story for why it happens.
No. Other people have, in fact, done that. Other people have, in fact, done what you said, which is go out, they found bits of stuff, and they melted it, and they experimented with it, and they discovered, well, this stuff.
I know, and that's not prediction.
This stuff is. That's just a minute. Prediction, just a minute. And based on all the experiments that they did, they came up with theories about why these things behave the way that they do, and then they tested those theories. Some of those theories turned out to be true. Most of them turned out to be wrong. And so we have a history of hundreds of years of this, and based on that history, we have knowledge of how things work. And based on that knowledge, we can construct new materials, things like nylon, things like different polymers. We can take petroleum out of the ground, and based on chemical theories, we can make gasoline or kerosene. We can make all kinds of things. We can make airplanes.
You're not making these from theories. You're making them from the actual physical things and seeing how they react. You're not going to just
I understand.
but this is what you know. But hold on. What you're saying is we.
Okay, guys, that's. Hey, guys.
In making new things.
That's you done on your 5 questions. So.
Okay.
Would you
I'm
like?
happy.
Would you like an extra 15 minutes? That's the main thing. Would you like an extra 15 minutes?
I'm willing to go as long as you wish, as long as anybody else wishes. Sure, I can go for another 15 minutes if you like.
Right, hand. Would you be happy to do another 15 minutes? You can address any of the questions that you've already gone through.
Yeah, that's fine. That'll work.
Okay. So
Wonderful.
I want to address the fact that you seem to think that we can't know anything unless we do it ourselves, and that's not true. We have a community of other people, scientists, who have done the previous work on which we can build. We can, as they say, stand on the shoulders of giants, of the people that come before us. So we don't have to constantly reinvent the world. Right? And that's how human progress is made. And the theories that they come up with guide us in constructing new and different things. Like the computer that you're using right now could not work without quantum mechanics, without the atomic theory.
That's absolutely incorrect, because and I've made a video on this, I don't know if you've seen this, you can make a computer based simply on the trial and error and experimentation of how matter will react to electricity in reality. If you had nothing but every component in the world, a welder, a solderer, and all that, you could make a computer eventually. You would just have to piece all the things together, because that's how they made a computer in the first place. Do you think that somebody...
That's
hold
not
on,
true.
That's a lie. Somebody
that's
wasn't
a lie.
Hold on. Somebody wasn't
That's
just sitting around. Somebody wasn't just sitting around and going, I think iron will behave like this when you add electricity to it. You have to add electricity to it to see how it will behave.
No, that's exactly how the transistor was discovered. The people who discovered the transistor knew what quantum mechanics said.
How did they know that? How did they know that?
They knew it because they were... What are you talking about?
How do you know how something's going to behave before seeing it behave like it will?
Because we have knowledge about these things. We know because our theories are true.
You don't have the knowledge until you do the experiment and see how the matter will react. So you're saying that you have predictions. False. You don't. Okay, so then here. So without, and this, I asked this to you before, and you just rambled. Without actually electrocuting a metal, how can you find out how it's going to behave?
Based on your one's knowledge of quantum mechanics and material science, you can predict, and material engineers do this. They can construct custom materials that have the custom properties, the desired properties, based on their knowledge of alloys and material science and how the world actually works. Our theories of the atomic theory of matter and quantum mechanics is true.
Why it's true because you say it is?
No, it's true because we have verified that it's true.
Okay,
We've conducted the experiments. Other people have conducted the experiments. And once a theory has been shown to be true, then it's no longer needed to do that. Other people can take that result and build off of it and construct new theories based on those.
Okay, well, let me sum up your argument. You've never done any of the things that you believe are happening. Other people have.
That's false. That's false. That's an assumption on your part. No, you're wrong.
You said it yourself.
I have.
You said smarter people have machines that you don't have. Okay, so if a lot of this stuff you've never done,
That's
okay,
false.
how do you know it's... All right, Brenda.
That's
Well, look,
false.
man, the problem is that you're trying to assert something as being true when you have no backing in reality to do that. Only your faith in other people.
That's false. That's a lie. I have done many of these experiments in chemistry and physics classes when I was in school. We didn't just read it, Rightthe. We didn't just read from a book. We did experiments based on the learning material, and we confirmed for ourselves that what the book said was true by doing the experiments ourselves.
You think turning on a light is an experiment that proves photons?
No. We did the experiments ourselves.
No, this is my point.
We did not read from a book.
And said, I turn on a light. Hold on. If somebody told me I turned on a light as an experiment or photons are real, I would laugh. And then if that same person told me we did some similar experiments in high school that proved photons, I would laugh again.
No, but we did the actual experiments where you turn on a light or you burn a material in a Bunsen burner, and you look at the through the spectroscope, and you can see the lines that indicate what it's made out of, whether it's made out of copper or iron, right? They have different spectroscopic lines. We did those experiments in in physics class. We did them, and we confirmed for ourselves the truth. We took Ptolemy's actual observations, and we constructed the orbit of the Earth ourselves. We did the math.
Okay, math doesn't prove that a rock will float in a vacuum, just like turning on a light doesn't prove that a photon is flying out of the filament.
Let me do the thought experiment for you once again. You have a cloth bag. And into that cloth bag, I put 2 apples, and Sally puts 3 apples, and we close the bag. How many apples are in the bag? You can know how many apples are in there by doing the math. Math is a tool.
You will only know how many apples are in there by looking in the bag and seeing. Yes.
That's
because
wrong.
How do you know Sally put 2 apples in there? Maybe she just said she did. Maybe Sally is a liar. So how do you know that Sally actually put 2 apples into the bag unless you open the bag and see for yourself? This is why math does not prove reality.
You saw her put 3 apples in there. You saw me put 2 apples in
there.
Them
back out. Maybe there's a hole in the bag. Maybe it's a magic bag. The thing is, you don't know how many apples are in that bag until you look in the bag and see them.
You can.
You can believe that you.
Yes, you can. You can know. You can know.
Okay, you can know with certainty. Bag you can't. Okay.
You can know.
You want to? I'm perfectly happy ending this on Brenda saying she can know what's in a bag she cannot look into.
That's right. I can know what's in the bag. I can know there are 5 apples in because Sally put 3 in and I put 2 in. And the bag is closed. We can't see. I know there are 5 apples in the bag. You can't figure it out.
One question for you. If you said, I know there were 5 apples in the bag, and somebody came up to you who wasn't there before and was like, how to prove it? What would you do?
I could do a couple of things. I could open the bag, take the apples out, and count them. Or I could tell them that Sally put 3 apples in, and Brenda put 2 apples in, and therefore there are 5 apples in this bag. And then that person could say,
I don't believe you. What if they said, I don't believe you? Prove it. What if they're like, I don't believe you put 2 apples in there. Prove it. What would you do
you could empty out. Then you could empty the bag and count the apples that emerged from the bag.
Okay, so we agree that the only way to prove something is not with math, but with the physical objects in reality. Congratulations. You agree with me.
Isn't counting math, right, the hand?
No, counting is touching a physical object and quantifying that with concept. Math is not real, Brenda. Math is not real.
Math.
Show me 4. Show me 4. Show me 4 Show me 4 without a physical object. Show me 4 without a physical object.
dude.
Show me 4. Show me 4.
Excuse me, you need to stop interrupting. You have this habit of getting spastic and talking over people and not letting people talk. The only way, listen to this. Even emptying out the bag and spilling them out onto the table, you still have to use math to know how many apples are there. You have to count them, and counting is math.
Yes, but math is not reality. The apples are real. The math is a concept you're applying to reality based on physical things in reality. So when you say that math proves things, it doesn't. It cannot. Math cannot quantify the causation of anything. It can only quantify numbers of and speed of. That's all you're doing.
When I use math, which is counting, to count 5 apples on a table, I am not saying that math is reality. I am using math as a tool to tell me how many apples are on the table. You seem to be really stuck. You seem to be really stuck on this.
Because you're not using math. You're looking at the apples and physically seeing the apples to know how many are there. That's not math. That's physically seeing them. Now, when we hold on, when we apply that same situation, okay, to atoms, you will have to only use math because you will never see the apples. And that's my point. You're trying to make something that is real in a probability aspect tangible. That's what you're doing. And that's where you're wrong.
Listen to me and allow me to explain this to you. I have a table. I have 100 apples on the table. I can't look at it and know how many apples in there. I have to count them. I have to use math.
No, you have to touch the apples.
I don't have to touch them. I don't have to touch them.
Okay, so if they're in a stack, okay, hold on. If they're in a stack, right? Say they're stacked up where you can't see the interior. How are you going to know how many are there?
I could estimate. I could measure how large the pile. Just fucking let me fucking talk, you piece of shit. Let me fucking talk.
Brenda,
Shut up.
If it was stacked,
stacked
on a cardboard,
Shut
stacked
up.
on a cardboard box, you couldn't. How do you know that there are apples underneath apples?
Shut up.
No,
Shut up.
We got.
Shut up. Let me talk. The way you would do it is that you would measure how wide the pile is, how tall it is, and you could make an estimate based on how many apples fit within a certain area, and then you could do math to figure out how many apples would fit into that. So let's say it's 1 million apples. I could estimate the size of that pile, and I could based on how many apples fit within a certain unit, I could measure it, and then I could do some calculations, and I could come up with a very good estimate of how many apples are in that pile that's, say, 100 feet tall and 100 feet wide, and it's pyramid shaped, right? Then I could do the math. I could do the math, and I could come up with an estimate. All of these examples.
Did your math take? I know, I understand. Did your math take into consideration the fact that I stacked all of those apples on a box and there's actually nothing inside of that pyramid?
No, it didn't.
Okay, so then math doesn't do shit for the real world, does it?
Yes, it actually does.
Well,
it gives me a high. Write the hand. It gives me a high degree of confidence. Right, because
not a box for the apples.
Right, it doesn't give it an estimation like the one we're talking about now, where you have 1 million apples. I would have a high degree of confidence, right? I wouldn't have absolute certainty.
Okay, so you can't prove anything with math. You can't prove anything with absolute certainty. That's my point. Thank you, Brenda.
That's wrong. That's just wrong. That's not how this works.
You just said it. You just said you cannot prove it. You can only get a close estimate. That was your words.
Yes. And
okay, so your
degrees.
Your words. You cannot prove something with math. You can only get an estimate.
That's knowledge.
No, that's an estimate. Knowledge would be counting the apples.
That's right. Could
I just intersect for a second here, guys? Because obviously we're talking about quantum mechanics here. So Is there anything that you guys want to address over the original questions that you don't feel were properly answered the first time around, or you didn't have enough time to actually get anything through? Because it seems like we've just been talking about this apples and thing for the last 10 minutes or so.
Well, Rightthe has a very bizarre understanding of mathematics and its role in the sciences. Mathematics is a tool by which we can know things. And he also has a common idea that a lot of people have, that if you don't have absolute certainty, you don't know anything, and that's false. We can have degrees of confidence, and those count as knowledge. So I can have a high degree of confidence that my estimate of how many apples are in that 100-foot tall pile, I can say that I know to a certain degree, and I can quantify the degree of error that I might have, and that constitutes knowledge.
Okay, I would counter, and I'm going to end on, I don't believe you have knowledge when you just use math. The knowledge comes from the actual physical interaction of the physical matter and seeing it and interacting with it. You cannot say how many apples are in a stacked pyramid or how many atoms are in an iron block with math. It doesn't work.
Yeah, you're just wrong. Math is a form of knowledge. I
proved it. Oh,
no,
okay.
you didn't.
Well,
No, you didn't. Math.
But math doesn't account for things that you can't see. You just said that math doesn't account for the fact that hold on. You just said that math doesn't account for the fact that there could be cardboard under those apples, making it look like it. Just like you can't account for the fact that there could be something similar going on with an atom that math does not account for.
Well, Rightthe, if I thought, for instance, that there was in fact cardboard or some other thing beneath the pile of apples that was giving me the wrong answer, I could test for that. And people can and do test. That's what the testing part. That's what the testing part of science is to make sure that our hypotheses and our theories are correct by testing them to make sure that we haven't made a mistake. So I would test it.
Test how many apples were there?
To test if in fact there was, for instance, a void inside of the pyramid of apples, I would.
Okay, guys, I'm going to give you 1 minute each to wrap this up. It's been very entertaining. Yeah. So, Brenda, if you'd like to go first, and then Rightthe.
Okay. Well, I think the main takeaway, it has nothing to do with quantum mechanics. It has to do with a very distorted and, in fact, perverted understanding of math and science and how math relates to science. It is a tool, and it is also a perverted understanding that unless you have absolute certainty, you can't know anything, or unless you do something for yourself, you can't know anything. And these are all false. We can know things with degrees of confidence, and we can know things based on what other people have done. With a high degree of confidence, we can know the world around us. And without these, we can't know anything. You would still be hunting deer with a spear.
Okay, Rightthe.
Okay, you don't need any of that stuff to advance, okay? So we didn't know about quantum mechanics when we made the first computer, okay? So that's not a point. The point is the only way you can get knowledge is from the actual real world and the interactions of matter and seeing how they behave and then constructing a properties profile of all of the matter against all of the other matter and when electricity is applied to it. You can't just come to the conclusion based on math and assume it, because even Brenda said that will not be an exact number, and if you're trying to make a computer or make something, you need to be exact, and exactness only comes from actually physically doing it and seeing it for yourself.
Right, well, thanks very much, guys, for stopping by. I'm going to shout out some of the super chats actually, because I've had quite a few today, so just bear with me, guys. So from Toady, good format, like the 5-minute limits. Guys, how did you think the 5-minute limits went?
I think that the format works out relatively well. How long have we been talking?
Well, we've been going for nearly an hour and a half now, so it's surprising how quickly things go.
I think that this format works relatively well. It did go a lot faster than I was thinking. Time dilation due to relativity.
Gravity D Biatch have given Brenda global tiitis, something like that.
I don't understand.
D Globe Zombies how to measure Polaris distance. Love all FE community. From Jennifer Winterburn, spinning balls bouncing around Brenda's tiny brain from Earth is seriously flat. Globe Zombies experiment Narnia. B-ball for math. Math is reality. If you have $0 in the bank and your rent is due, you're screwed. And from Jennifer Winterburn, laughing my head off, LOL at Brenda. So it's been quite the evening, guys. So. Thanks very much for stopping by. I'm sorry I keep saying guys, by the way. It's just my terminology, how I speak.
Do you want to take questions from the peanut gallery?
That's
up to you. It's your format, and it'd be up to Rightthe hand too.
What do you want? Do you want to answer a couple of questions?
Maybe you can get some more. Maybe you can squeeze some more super chats out of them.
Well, I'm not doing it for the super chats, Brenda.
I'm kidding you. I don't care if you make money off of this. It doesn't bother me one bit.
It's nice when you get a super chat, I have to admit. But that's not my primary goal, is it? It's I want a format where people can come in and they can debate, they can do presentations, and they can do it in a very structured and relatively nice way.
This format seems to work, if you ask me.
Rightthe hand. How do you think it went this evening? Did you enjoy debating Brenda, or did you feel it was something different to how you expected it would go?
No. I mean, it went as expected. No offense to Brenda, but I know he's very set in his ways and going to. I knew what was going to happen, but I think this was a much better platform than just screaming at each other over 50 people. I thought it was much easier to express the ideas, and I even said it the first time I was on here. It's like sometimes you almost don't know what to do when you're talking and somebody doesn't interrupt you.
Well, I think what I'm going to do now is I think I will wrap up. I don't think I'll take questions, but I think what will happen from this is that people will probably take some of the things that have been said and they'll scrutinise it, obviously, and they'll try to work around any strengths or weaknesses about your particular argument. And hopefully that, in the future, if we ever get to have these debates in the future, maybe 6 months down the line, hopefully the arguments will have progressed a little bit. Maybe some of the lines of questioning might be slightly different. Maybe some of the answers will be slightly different too. And that's what we're all after, is a bit of progress, somewhere where we can actually get some answers at the end of the day. So, thanks guys for stopping by. I'm going to round this up now. If you guys want to stick yourself on mute, and we'll have a little chat after this is finished, and I'll round up now. And thanks everyone for stopping by. I've had 140 odd watching, so that's absolutely awesome.
Well, I'll close this then. We're all done?
All done?
Okay.
Okay, speak to you in a bit. And thanks everybody for stopping by. That's all I can say. Hopefully see you on Friday, where I've got a couple of presentations ready for the round table. We're going to have a 6 p.m. BST and a 9 p.m. BST. And that's about it really, guys. That's it. Thanks very much. Sweating. But it's very hot, that's all I can say. Right, guys. I'll see you all in the next one.